comes from section 3.1. Number 1 has this equation, and it says it looks like this. Can't read that very well, but this is 1, and this is -1 right about here, and this is 2 and -2. So those are not very clear. And this is a height of 1. And it says critical points. Critical points are where the slope is. You can't find it. It's undefined, or it's 0, and it looks like it's 0 at 0. Inflection points. Well, this is curved up, and then it curves down. So somewhere in here, maybe at 1 or so, we think there might be an inflection point, and looks like it's curved down and then curved up, so there might be one at -1. Somewhere in there. Now it says use derivatives to find any critical points and inflection points. So we take the derivative, find f prime of x, and that would be derivative of ln would be derivative in the inside, 4x times the derivative of ln, which would be 1 over 2x squared plus 1. And this is 0 only when the numerator is 0, which means x has to equal 0. Okay? So critical points at 0. Now let's take the derivative again. So we have 4x over this. So we have to do the quotient rule. (2x squared plus 1). This is a prime b, so b is 2x squared plus 1 minus, and this is b prime a was 4x, so I got all the easy parts. Derivative of the numerator, derivative of 4x is 4. Derivative of the denominator is 4x. So if we're trying to make the second derivative of x, of the function, equal to 0, we're going to set this numerator equal to 0. That's not 0. X squared is always positive times, or 0 times 2. It's positive number 0 plus 1. It's even bigger, so this is never 0 in the denominator. We don't have to worry about undefined, but we get 8x squared plus 4 minus 16x squared, and we're trying to make that equal to 0. So we have 8x squared minus 16 is minus 8x squared plus 4 equals 0. Add 8x squared to both sides, and we get 4 equals 8x squared divided by 8. And we get x squared equals 1/2, and so x will equal the square root of 1/2, which in decimal is approximately 0.7071. So on our graph, it's not at 1, but at 0.7, where the inflection changes from curved up to curved down. 0.7071 and minus 0.7071. Plus the square root of 1/2, comma, minus the square root of 1/2, or that would be 1 over the square root of 2, or square root of 2 over 2, or you can put it in as a decimal. Number 3. Now this one's not going to work so well because it didn't print so well. Let me see if I can see that well enough to trace over it. We got a graph that looks like this, and then the other ones you can see. And this looks like, these look like polynomials. That looks like a parabola. That's a degree 2 upside down. And it's, if I took the derivative, it would go to a line. We don't have a line. And so this must be the second derivative. So the first derivative would be a degree 3, which would have to go something like that. So this must be f prime, and this one must be f. Now, they weren't expecting you to look at it that way, but let's just now look at this. The slope is positive, and f prime is positive. The slope is 0, f prime is 0. The slope of this one is 0 here, and f prime is 0. And the slope is 0, and f prime is 0. Now, if we look at the slope of this thing, the slope is negative. The slope of f prime is 0, so the second derivative is 0. Or, if you will, this is concave down. F is concave down, so the double prime is always negative. And then it's concaved up, so this one's above 0, meaning it's concaved up. And then it concaves down, and this is negative. Okay. So I think that means, by the labeling, that because of the colors, I think that's A, B, and C. But I want you to understand the graphs. Okay. This one, number 4. F is a differentiable function at every real value. So it's nice continuous. Almost looks like an x cubed function. And this is the derivative. So the original function is probably a degree 4, because this looks like degree 3, and the derivative should be a degree 2, a parabola. But anyway, f of 0 is 1/2. Now, they don't give you f0 graph. We're supposed to put it on this one, I think. So f of 0 is minus 1/2. So it goes right there. And f prime of x graph is given in the center picture. Okay? So now what do we got to do with this? Construct the first derivative sign chart. Okay, this is the first derivative. Below 1, this is negative 1. Below negative 1, it is negative. And in here, it's positive. It's all above the x-axis. And then over here, it's positive. So that means we have to be decreasing down here. At negative 1, it has to have a slope of 0. So it has to be decreasing, slope of 0 here at minus 1. Then it has to go through this place, they said, and then it's got to have a slope of 0 again at 1. So I can make it be at 0, or I can make it higher, have a slope of 0, or lower, but it goes to a slope of 0. And then after that, it has positive slope. Now, does that look like something that could be a 4th degree? Comes down, it turns, turns, turns again. 3 turns is a 4th degree. 2 turns, turning down to turning up, that's a 2nd degree, or 3rd degree. And so what's the second derivative look like? Well, the slope of this is positive, and it's positive clear to someplace in here. So someplace in here, the slope is 0, and the slope here is 0. Now, here it's positive, so this has to be positive up here, but let's just look at the concavity. This is concaved up all the way to someplace in here, and that's what this is saying. It's concaved up. It's positive. And then it's concaved down for a while, and this is negative. And then it's concave, this is concave down. Then it's concaved up for the rest of the time, which makes this positive. Or here it says the slope is positive. The slope is positive all the way through here. Yeah, slope is positive all the way through here. But this has a slope of positive getting to 0, getting a negative slope through here, and then positive slope again. And that kind of looks like a parabola, an x squared, degree 2, degree 3, and degree 4. Okay, and I think I've done everything they asked for there on number 4.